Alright, welcome back. I decided to go ahead and do a series, why not, tentatively. This is the very next day, same slide. And it hasn't been 24 hours yet. It is 4:17 p.m. Oh my god. Anyway, it's 4:17 p.m. EST. I did the slide yesterday at, what was it? No, I don't know, like 7 or 8 p.m., something like that. So in 4 more hours it'd be 24. And the slide has remained well sealed, so I got super lucky on that. So why not? Sure, as long as it's not drying out, I can just come back next day, as long as it's convenient, and show you how these kinds of slides, these kinds of samples degrade over time. You'll notice that all the algae have just quit. They're just like sitting around. Now you'll see one move through now and then, but for the most part, no. And you'll notice something else. Let's see if I can get the definition a little bit better on the background. The fast movers in between. See all those guys? Bacteria. This is what happens in a catastrophic environmental collapse. First the larger organisms die, then smaller, then smaller, then smaller, on down the chain. It's funny because we get this idea of superiority, right? Top of the food chain, humans, we are the alpha, the ultimate alpha. But what you don't realize is that makes us the first to go because our needs are so great. Okay, let's say a human being dies. Immediately you'll have flies, animals, bacteria, of course, but large organisms like carnivorous animals or animals that'll go after carrion will attack first, and all these smaller critters with it. And then after there's no meat left to consume, not to be disgusting, but this is the reality of things. After there's no meat left, some animals will try to attack the bones, whatever, but mostly the remaining scraps come down to things like maggots and bacteria and fungus and stuff like that attack. So let's say that's all you had is one human, a bunch of animals, and bacteria and lesser organisms. First, the human's gone. Then the animals go because they have nothing left to eat except each other. Then you have the flies attacking what's left. They die out because there's nothing left for them to eat. Funguses and bacteria, I suppose funguses would die first, and then at the very last the bacteria are the last to go. Or I suppose you could argue viruses, because viruses will attack bacteria. Some species will. Some species will attack some species of bacteria. So lesser, 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 and then finally at the end of the day nothing left. But so what you're seeing here is a nice representation of that. You'll notice the algae are all sitting still. If I keep the light on that spot, then some of them will wake and become more active because of photosynthesis. You can see the green. But for the most part, they're already done. Their fate is sealed. Ha! Literally. Because they're in a sealed slide. You see way up here, you see this? This is Vaseline. It's the barrier trapping the water. It's the barrier trapping the water in the slide, more or less permanently. I have some of these slides still that are, God, over a year old, maybe over 2 years old. I forget exactly when it was I started doing this. If you get the seal right, it's just a ring of Vaseline. connecting the cover slip to the slide glass. If you get it right, then it remains sealed indefinitely, and then it's just environmental factors trapped in that unchanging fluid medium that determine what dies when, how fast the whole thing falls apart, etc. Notice toward that Vaseline barrier, lots of bacteria. And this is not even 24 hours later. So there's a good look at the beginnings of it. Now what's going to be really interesting is these algae are basically soft-bodied creatures. Relatively speaking, soft-bodied creatures. So at some point they're going to start to die and decay and disintegrate. I'm not entirely sure what that's going to look like, but we're going to find out. There's one in process of division right there. It might make it, it might not. Doesn't really matter. The end is the same. Let me see if I can spot anything obvious as far as dead cells. Yeah, okay. Here, let me grab the little mouse arrow. See this here? It's kind of pale, almost transparent. Those I am pretty sure are dead. And a lot of these that look reasonably healthy may also be dead. They're just, taking a while to disintegrate enough, to degrade enough, to lose their color and their internal definition and whatnot. There's a really good example right here. This one is so pale compared to the others. It's very evidently not doing too hot. It's probably already dead. A lot of these are probably already dead. So, yeah, let's step out in the magnification. So that may be a bit too bright. Yeah, I believe so. Iris. That's better. Okay. Yeah, I guess that's got it. See how everything is just not going anywhere. Large protozoans scattered around. I didn't notice those. Just kept missing them because I was too high in the magnification. But see, everything's already got this very, very dead kind of look. My focus just seems really odd on this. I guess it's the position of the... Yeah, that's a little better. Position of the condenser. Can I get a little better on the glitter effect from the dark field? A little bit better contrast is what I was trying to say. Yeah, so see, the only thing moving is one specific species of protozoan, unknown, and the occasional single-celled, isolated cell algae. That's pretty much it. Can't see the bacteria at this scale, not yet, not until they get super crowded. You might notice a sort of a sparkle of noise grain. That's actually most of the time the bacteria moving around in large numbers. Yeah, here. Excellent example right here. See, it almost looks noisy. Tiny little particles moving around. That's bacteria. That's a large amount of bacteria clustered there along the edge. They have a tendency to try to escape their boundaries there. Believe it or not, they do. I don't know, it might have something to do with the local environment at that boundary there. Not really sure. Okay, step out one more level. Lower yet. And there we are. Very, very wide view. Gives you a good idea of the remaining activity across the slide. The drop's not very big, really. This troubles me a bit, but looks okay. Looks like just a gas bubble in there. That's not uncommon. When you make a slide like this, it's easy to trap a large bubble, and just, containing a drop of very living media can create gas bubbles within it over time as things progress. Yeah, strangely enough, looks like I have a big problem. That shouldn't be happening. Yeah, okay, I got a breach. See this? These things flowing out in one direction like they're on a river? That's because I've got a breach. And you can see the continuation of it there. Outflow going on. It might or might not fix itself in... Oh, hello. Huh. I wonder if they're all 1, 2, 3, 4. I wonder if they're all brothers and sisters. I bet you they are. 2 of them got trapped, or 1 got trapped, and over time they've multiplied. I am concerned about that outflow. I think I might have a fatal breach. It's drifting out that way, but then again too, they can actually heal themselves as the fluid level goes down. They can, the weight of the cover glass, especially being pulled by the rest of the Vaseline, can actually cause it to squish together and seal a breach. And it's actually fairly common for it to do that. Let's take a look at that boundary. Yeah, this I like. Nice, oh nice. Good view of them for once. They're kind of trapped, so that thankfully gives me a chance to study them a little better. Let's open up the iris. This is going to get lengthy. I hope you all are going to be patient with me for a bit. Here we come. Don't hit that cover glass. Although that might help with the breach. Give it a little smack. Could actually do that on purpose. It's not like I've never hit the cover glass with the objective before. God, how many times. With the very high power objectives, it's easy to screw up that way. And we're in. Okay, you can see the outflow of the breach there. Everything's flowing that way. Oh yeah, a lot. Didn't notice that at the lower power. It's a problem. Okay, these guys. Very nice. Get a good look at them finally. Earlier when I tried to get a look at what happened to the, oh, okay. When I tried to get a look at those guys, I knew that wasn't going to work because they're just too fast. But ooh, look at the cilia. Ooh, that's beautiful. Very nice. Look, nah, super arrow again. Oops, my bad. That still cracks me up. Anyway, the white arrow. Okay, so yeah, we got some larger protozoans piled up here, which is great, and they are reasonably trapped. So now I can show you the finer points of protozoan anatomy. I don't see any large size. Yeah, I do, right there. That's it. That's probably a centriole vacuole. Yep. Notice how it went pinch. Those do water regulation and waste removal. As far as I know, waste removal inside the cell. It opens up wide like that, and then it'll clamp. See that? And when it does clamp, you'll see this kind of illustrated in textbooks sometimes. When it clamps, it forms a star kind of pattern, like it's been pinched. And you'll see that in textbooks. And if you're just a skimmer like I was when I was a kid on this stuff, you'll see that and you'll be like, I don't see it in my slide. Where is it in the paramecium or whatever? It's like, it's not like that all the time. And shame on them for illustrating it as if it's always there. No, I don't fault them. It's beautiful art. It truly is. But but yeah, no, you only see that when it pinches closed. The rest of the time it just looks like a sphere. And yeah, these are big guys. I don't know what they are. They're not paramecia, but they're similar. Very flexible. Look at that, squirming around. Squishy cytoplasm. Yeah, and then there are these smaller ones, and then the algae, of course. And oh my god, the bacteria counts are already so super high. It's explosive population growth on those. They have nothing but resources, where these guys are just, dying out hard. So, the bacteria, as I said, are free to explode out of control. And that will kill the slide very quickly because toxins from the bacteria and depletion of resource, it's gonna wreak some serious havoc on that. This guy's got a mouth groove. Huh. Well, I suppose it could be a paramecium. Maybe I'm just... Yeah, see that? Definitely a very similar structure anatomically to paramecium, the mouth groove there. And all the basic parts is obviously full of algae, and they're really squashy. I don't remember paramecia being so squishy, but yeah, maybe. Definitely got all the characteristic layout, just not really happy with the look overall compared to paramecium. It just doesn't seem quite exactly right. I don't know, maybe I'm being overcritical. Probably am. Very nice view of them. Very impressive. Should I cut it here? Probably, I suppose so. There'll be more coming. I'll keep doing it until it just doesn't seem like there's a point anymore to doing it. So I'll be back, tomorrow, right around the 24-hour mark, and again until the point of the thing runs out. Anyway, yeah, so, hey, that was cool, right? Pretty cool. Jeez, look at all the bacteria. Crazy. I didn't expect the numbers to be so high, even though I've done this again and again. I should have. These guys are interesting here. I don't know exactly what they are. I've seen them before. Just don't know their species. Isolated populations, see, they're all trapped. So what was there is now increasing in number because they have nowhere to go. So anyway, I'll let you go here, and thanks for watching as always. Sorry this was a bit long, but how else are you going to cover everything? Bye for now. See you next time. Hope you're having a great week. Take care. Where's the stop? Bye.